Alright, welcome back. So we'll continue on with these. See if we can't get these done today. Alright, so we're at C and we have y equals x cubed. Sorry, we jumped ahead there. X cubed minus 6x squared minus 15x minus 4. So we want to assign this to 0 if it's at all possible. So we need to go ahead and find what that is. So we get 3x squared, 2 6s is 12x minus 15. So we can go ahead and see if we can assign this to 0. So this becomes solved, it's a quadratic. So there's a number of different ways that you can do it. You might like to use the quadratic formula. It seems popular amongst some people. So that's what we set that to. I'm going to just do a thing. So that is 45 minus 45x squared. The factors of that are 5 and 9, plus or minus to some degree, x, but I'm not worried about that at this point. Further, I think 15 and 3, plus or minus 15, 3, 15 and 3 will give you that, won't it? So I'm going to rebuild the middle term. This is called grouping in pairs if you're interested. So 3x squared minus 15x, that looks okay, plus 3x. Well, that gave us our sum term, so this one's a bit more sensible. Okay, equals 0. So the idea here is that we group them. Maybe if I group the 3's together. Group the 3's together. So I take 3x out, I'll get x plus 1. Now the idea of grouping in pairs is that that's a repeat. I don't even have to think too hard about that. But I've got to put a 15 in and get this one and this one. So what have I got to put? Oh, it's minus 15. There you go, that works. That gives you 15x and minus 15. So our two factors are linear factors, the 3x minus 15 and x plus 1. So that was a doodle, wasn't it? Another technique, you see. If you hang around, you might pick some things up. So we've got a couple of different things here. We've got when is this true? When x is equal to -1, that's when it's true. It's also true when this term here is 15, so that would be 5, so x would have to be 5. So what we expect is at these 2 points, m equals 0 at these 2 points. So it's a little bit of a work to get the values out, isn't it? I should make up a spreadsheet or something that makes it a bit easier. But so we would put in y into the -1 just to get the y coordinates, and that would give us the y coordinates. So I can do that just by quickly computing them. So just clear all this stuff away, and that's fine. So the first one we're checking is -1. So -1 to the power 3 equals, pop that into memory, -1 squared times -6. Pop that into memory. -1 times -15 equals, pop that into memory, and -4. Pop that into memory. And so if we clear all that, we should get a value for this one. So -1's at 4. We just got to run through and complete all that again. Clear the memory out. Move all the noise away. Let's try again for 5. So we've got 5 to the power 3. And we pop that into the memory. And we've got 5 squared times 6 minus. And add that to the memory. Got 5 times 15 minus, drop that into the memory again, and minus 4 one more time. So that's fairly straightforward. So it looks like we've got a 60 there. Okay, all well. Alright, so what we can do is, in the first derivative we can have a look at it, and we can put it across like this, where we've got these values of minus 1, 5, and what we're expecting is that there'll be zeros there, and what are they actually doing? So we'll have a look at the some values below. So let's have a look at minus 2. What does minus 2 give us? So if we put a minus 2 in here, and what's between there? Oh, 0 is a good one. And what's up here? Maybe 6 or something. Maybe 6. That would give us a bit. What's 0 look like? 0, that's gone. 0, that's gone. 0, that's minus 4, so that's a negative. Okay, so at 0 we had a negative value. Sorry, I should be checking the. So 0, 0, still we had a negative value, so we're checking these here. Alright, what about minus 2? Minus 2 is 4, 12. Minus 24 is minus 12, minus, so that's a negative. That's interesting. So we better check that. Minus 2, let's just see what that value looks like. So we've got minus 2. These are the M curve. This is the idea of the M curve. So just checking what minus 2 would look like. So 2 minus squared, let's clear the memory away. 2 minus squared times 3. I'll add that to the memory. Minus 2 times 12 minus. So we'll add that to the memory, and 15 minus. I'll add that to the memory. Now if we get that back, getting a positive, that's good. That's good. We've got increasing up to a max, up to this, and then decreasing. So this looks like it's a max. So that's good validation. We checked our 0, so that's good. And let's check our 6. So we've got clearing our friend here, clearing away the debris. So we're checking 6. So 6 squared times 3 is that one. Put that in the memory. And 6 times 12 minus. Didn't quite come out the way I wanted it. 6 times 12 minus is equal to this. Add that to the memory. And minus 15 again. Add that to the memory. So we clear that away. Pull back the memory, and we get a plus. Great. A plus 21. So what that tells us is that we are in fact going down, 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 and then up, 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 up. So this is a minimum. So we've been able to secure that way. Alright, the next thing we'd like to do is check our two values at y double dash. So y double dash is 6x minus 12. And so using function notation, we can drop that in. And we get minus 6 minus 12, which is minus 18. Checking our double dash again for 5. We get 6 times 5, which is 30. 30 minus 12 is 18, but it's a plus 18. So that validates our concave down and concave up locations. So what we're able to do then is to draw this up, and let's see what we've got. So at minus 1, that's our point there, and 5. So at minus 1 we had 4. So that tells us that. But we already know that we've got these. And 5 was 60. 5 was 60. So let me just check that, because that feels wrong, doesn't it? I did do 5 up there. Let me do that again. Doesn't take that much time, does it? Just a little bit. So 5 to the power 3 is equal to 5 squared times 6 minus. That to the memory. 5 times 15 minus. Add that to the memory again. And 4 minus. Let's clear that. So 4 minus, and add that to the memory. Minus 104. I was way out. It was I kidding. Minus 104. I was way out. Unbelievable. Alright, so we get a minus 4, which we'll mark off as the y-intercept. But minus 104 is going to be way down here. And so we'll exaggerate that break. So we've got this. So that's now looking a bit better as well. So we expect there. Now the final thing is to check your double derivative, set it to 0. So we put 6x minus 12 equals 0. So you do all the steps. 12 on that side divided by 6. It's 2. So we get this point here somewhere that's 2. And 2 into the main picture up the top. Once again, 2 cubed is 8. Y2 we need. So 2 cubed is 8. Minus 2, 2's a 4, 6 is 24. Minus 30, minus 4. So we can bring the 8 off 2 8s. So that's minus 16. That makes minus 20. And minus 30 is minus 50. Also, it's still a long way down. 2 is minus 50. That's somewhere way, way, way down here. So that means that we're going to be swooping down quite a bit. Swoop, swoop, swoop. Keeping that outside swooping happening to there. So that's a bit distorting, but it's not too bad. And then there's a change of concavity that takes it down to here. So that's your whoop, whoop. So that's our point of inflection. And then this speeds off in this direction. And this one plunges down here like this. So it'd be interesting to see if we could have a look at that. See whether or not we get some validation. So x3 minus 6x squared minus 15x minus 4. So again, the scale's hiding the 4, but it's come up over there. So that's fine. That looks very, very good. Alright, so, and the scale's betraying that a little bit, but yeah. Alright, so that's good work on that one. Now we'll go for D and we'll have a look at D. So we're aiming to get this. So we have to establish this first. There we go. Then we have to solve by setting it to 0. So adding 3 to both sides. Dividing by 3. So x squared is equal to 1. So x is equal to plus or minus the square root of 1, which is just the plus or minus 1. So those 2 points, we expect to find x equals m equals 0. So we could just test that at plus or minus 1. Let's see what's happening above and below. There's 1. Alright, let's test 0. So at 0 we would be having 3. Minus. Okay, that's good. Minus. At minus 2 is 2 2s are 4. So we're looking at minus 2 in this direction. Minus 2 is 4. 4 3s are 12. 12 minus 3 is just still a positive. So that's good. We've got the change that we're looking for. Okay. And up here we can try 2. And it's going to be the same thing. It's going to be a positive, isn't it? Okay. So you can put those numbers in for your interval to justify your faith in the fact that it's a changing feature. The other thing we want to do is consider the second derivative. And the second derivative is 6x. And so we want to put these functions in. And we'll get 6, 1, which is plus 6. So that's a smiley face. And y minus 1 is 6 times minus 1. So that's minus 6. That's an upside down face. So the final thing then is to do the second derivative assigned to 0. So 6x is equal to 0. We're solving that. So therefore x is 0. And by symmetry we pretty much guess that that's going to be the case. But the 0 value for this would be 5. So the counterpart for this is 5. And we also had a y-intercept of 5. So it's coincident again. It's coincident with 5. So we can put this down here. We know at plus or minus 4 there's a turning point. Plus or minus 1. So we didn't check that, but 1, y1. Just getting the y coordinate, y1. 1 minus 3 to minus 2. Minus 2 plus 5 is 3. Y negative 1, because that's the other point, is minus 1 plus 3, which is 2, plus 5 is 7. So let's just check that. 1 minus 3 is minus 2, plus 5 is 3, and minus 1 plus 3 is 2, 2 and 5 is 7. And with 0 we already worked out. So we've got plus or minus 1. We have 5. And our values are 3 and 7. So minus 1 was 7. And 1 was 3. And we had 1 is a smiley face. And minus 1. So we can clearly see what's going on here. And this is our point of inflection. It's coincident again with the y-intercept. They're not always like that. But essentially what happens now is this comes down, swoops down, and then changes its swoop. That's it. And then it goes off. And this one comes down like that. So, very interesting. We've been able to show the features of that one. So I'd like to see this in minus 3x plus 5. So we've got this root that we haven't established, but that's okay. And we've got the 5, we've got that lovely shape. So we're doing quite well with our calculus and curve sketching, and that's all you're being asked to do. Alright, that's about 20 minutes. That was D. So I will pause there and finish the next two on another video. Back soon.